Our computers use virtual memory to run many programs efficiently. This system maps logical addresses to physical memory. Main memory, however, has limited space. When a program tries to access data not currently in main memory, a page fault occurs. The operating system must then retrieve the required page from slower secondary storage. To make room for this new page, an existing page in main memory might need to be removed. This is where page replacement algorithms become crucial. A page replacement algorithm is a strategy used by the operating system to decide which page in main memory should be replaced when a new page needs to be loaded. The goal is to minimize page faults, thereby improving system performance. These algorithms operate within a fixed number of available memory slots, often called page frames. Choosing the right page to evict is critical, as an incorrect choice can lead to frequent page faults, slowing down the entire system significantly. The first in, first out, or FIFO, algorithm is one of the simplest page replacement strategies. It operates on the principle that the page that has been in main memory for the longest time should be the first one to be replaced. Imagine a queue where pages enter at one end and exit at the other. When a page fault occurs, the page at the very front of this conceptual queue is evicted, making space for the new incoming page. This method is easy to implement but does not always yield optimal performance. Let us demonstrate FIFO with a simple example. Consider a main memory with 3 page frames and a page reference string 1, 2, 3, 4, 1, 2, 5. Initially, frames are empty. Page 1, 2, and 3 enter. When page 4 arrives, page 1, being the first in, is replaced. Next, page 1 arrives, replacing page 2. Then page 2 replaces page 3. Finally, page 5 replaces page 4. Notice how the oldest page is always evicted, regardless of its usage frequency. The least recently used, or LRU, algorithm aims to improve upon FIFO by considering page usage history. LRU replaces the page that has not been used for the longest period of time. The intuition here is that pages used recently are more likely to be used again soon. This algorithm requires tracking the last time each page was accessed, which adds complexity compared to FIFO. However, LRU often performs better by reducing the number of page faults. Let us demonstrate LRU with the same page reference string 1, 2, 3, 4, 1, 2, 5, and 3 page frames. Pages 1, 2, and 3 enter. When page 4 arrives, page 1 is the least recently used, so it is replaced. Next, page 1 arrives. Page 2 is now the least recently used, so it is replaced. Then page 2 arrives. Page 3 is the least recently used, so it is replaced. Finally, page 5 arrives. Page 1 is the least recently used, so it is replaced. Notice how usage dictates eviction. Both FIFO and LRU are fundamental page replacement algorithms. FIFO is simple to implement but can suffer from Belady's anomaly, where increasing page frames can sometimes increase page faults. LRU generally performs better by leveraging locality of reference, but it is more complex to implement due to the need for tracking page usage. The choice of algorithm depends on the specific system requirements and performance goals. Understanding these strategies is key to optimizing memory management in operating systems.